This demo will show an overview of how the dependency graph works in Maya. A curve is created with the CV creation tool. Then a revolve surface operation is applied. As the operator uses Maya through the standard user interface, the dependency graph is automatically created. The hypergraph is the visual representation of the dependency graph, which, in this example, shows how the surface was created. The curve-shaped node is connected to the revolve surface operation, which is, in turn, connected to the resulting surface shape. Each box represents a node in Maya. Nodes have sets of attributes that control its function. These attributes are connected, as shown with the arrows, which allow information to flow from one node to another. A network is a series of connected nodes. Sophisticated behaviors can be created by developing complex networks. As attributes change, the dependency graph automatically reevaluates the necessary nodes to reflect the changes. For example, moving a CV on the original curve affects the revolved surface. This is accomplished in two phases. The first phase is called dirty propagation, where each downstream affected attribute is marked out of date or dirty. In phase 2, each relevant node is recomputed to show an up-to-date scene. This process is very efficient because only the necessary nodes are recomputed. An example of this is animating the end sweep attribute on the revolved surface. Here, two keyframes are set on the end sweep to provide an animated surface of revolution. The animation curve controls the end sweep attribute on the revolve surface operation. Attributes can be animated in many ways, by keyframing, expressions, and direct connections. By breaking the connection between the animation curve and revolve surface, and reconnecting the revolve and sweep attribute to the global time node, a new method of creating the same effect is achieved. In this case, the current time drives the end sweep attribute of the revolve node. In the dependency graph, we have seen the procedural steps of how objects are created. Further details about the scene can be found in the Direct Acyclic Graph, or DAG. Here we see how objects are grouped or parented to create hierarchies.